It writes it a little bit differently. So, what's that? Anyway.
They are! It's on the news! I heard it this morning!
Your chances of being involved in a terrorism plot are, you're more likely to get struck by lightning.
Okay, but still, you have to be careful.
No, you can't go to Black Friday shopping.
Okay, I'm just looking out for Sydney's well-being and this is what
Target be held. Illinois.
Yeah.
they could.
Watch out for Walmart.
No, Target. They're going to Targets.
Because there's a Target there? They're going to Target practice?
I get it.
Yeah.
I get it.
They're Target practicing people at Target. Yeah, but they are. They're coming to Target and
Hey, Maddie,
Black Friday.
do you-
Be ready.
Do you have a computer?
Yeah.
Just shop online.
Yeah.
Did he say?
See?
Anyway,
They're listening to us right now, Mr. Murphy.
Anyways.
exponential growth or exponential functions. What they do here is they will change this a little bit differently from what you guys have seen in the past. They write it in terms of a to the x. I'm going to write it a little bit differently. I'm going to go back to what we did, b to the x. Remember we did that last year?
No.
When you had exponential graphs, we would say f of x
Yeah.
equaled a times b to the x. Well, that value of a was like your scalar. B to the x was your base raised to the exponent.
It's ISIS. You guys call
The-
that every day.
I just forgot what that was.
The other thing that gets thrown in here is that you're going to have, when you're walking, jeez. The book will also, you guys probably remember it like this. Y equals a b to the x minus h plus k.
Yeah.
We used exponential stuff like this last year with a, b's, h's, and k's. What, what this book is, they change it ever so slightly, is they write it in terms of, excuse me, they write it in terms of a, b's, and c's. It's really kind of weird. They'll say f of x equals b plus or minus a to the x plus, or x minus c.
Oh,
So.
Now, it's not a big deal for right now to worry about the way that they're writing it. You can go back, and I'm going to probably fall back into the way that we did it last year because it makes a lot of sense. Because you know, there was that horizontal component shift, there was that k vertical shift. The reason they do this with b plus or minus a to the x minus c is that when we get to trig, remember last year when we graphed sine, cosine, and tangent, we had all the h's and k's with that as well. What's going to change for us in pre-calc when we do that is that we're going to have, instead of just having like x minus h, they're always going to have that a value in front of that x in the side of the parentheses, so we'll have to be factoring out a lot of times. So they write it a little bit differently. So they're just trying to get you in the habit of seeing it. To be honest with you, in the grand scheme of things, it's not that big of a deal if we fall back into between these two here and here. I think this is kind of confusing for exponential because when you're worried about exponential growth and decay and just the functions themselves, there were a lot of little subtle nuances that were thrown in there. You had that horizontal asymptote at y equals 0. When you shifted to k, that asymptote went up and down. So your asymptote was at that k value. I don't know if you vaguely remember any of that. It's just these little bits. A lot of times when we deal with these things, we're dealing with very easy numbers to work with, tables. We're going to be using negative exponents, positive exponents, things like that, just so you can see what's happening on both sides of a graph. So let me just kind of walk you through a couple of things that they're going to do today. How we set up the graph. Oops. If it's the graph, oh, that didn't show up at all, did it? I'm going to write it as b to the x and b to the negative x. And we're just going to pick some base value, like 3. 2. We'll use 2. Okay. And we'll just kind of walk you through what the graph looks like. So let's say we have y equals 2 to the x. Remember, anytime you guys started working with graphs, the easiest thing to do was always to make a table, and you pick easy numbers. Couple negative, couple positive, and what else? 0. Bless you.
Thank you.
When you have 2 to the negative 2, what is that? You're right. 1/4. Yeah. You started to say 4. I thought you were about to say 1/4, so it's 1/4. What's 2 to the negative 1? 1/2. Remember your properties of exponents. What's anything with the 0 power?
1.
What's 2 to the first power?
2. 1. 2. 2. Because it's to the first power, so it's 2.
And 2 squared. You want to jump for that one? You sure? I was wondering about it for a second there. Okay. I wasn't spinning it. So your graphs on these things were relatively easy to work with. Excuse me. So we had -2, we're at a 1/4. -1, we're at a 1/2. At 1, we're at 2. And at 4, we're at, or 2, we're at 4. So it's going. Okay. Will that ever reach 0? No, it just gets smaller and smaller and smaller. So you wind up with a horizontal asymptote at 0, at y equals 0. And that's where that vertical shift, that k value, if there was some k, that'll shift that up and down. You always have your y-intercept. Y-intercept is going to be at 1 because there's no scalar out in front of it. It's at the b value if there's nothing out in front of this. To be honest with you, I was looking at the book, and I don't think there's anything that they give you that has that scalar thrown out in front of it. And this goes from there. When we do the other graph, b to the negative x, basically you're just doing the same thing. You're using tables again. And then this one, we'll use that -2. So this is b to the -2, so that's basically 2 squared. So you get 4, so it just goes the other direction when it's opposite around. So you're going to wind up at 4, 2, what is b to the, or 2 to the 0 again?
1.
Making sure. So if you go 2 to the negative x, same basic idea. You're just substituting in values and charting it through. Yeah. What's that? Oh, yeah. I just rewrote, they write it as y a to the negative x. I wrote it as b to the x. We're used to seeing it as b. It's a base to an exponent. That's all. Okay. Yeah, because that'll help, I think, also when we start talking about logarithms again with bases and all that. It'll be easier to keep with b's. There's parent functions. These would be your parents. Then you would shift them horizontal or vertical just by adding or subtracting your h's and k's. Nothing crazy, nothing you haven't seen, nothing you've never tried before. It's really, really simple. Yeah, we'll go back to those. The way I write these things out, just like I said earlier, with in terms of the old algebra 2, is that you'd have it where k is that boundary on your range. Depending on what your graph is doing, whether it's increasing or it's decreasing down, that k value is going to give you an asymptote. It's going to be the horizontal asymptote at k, and your graph's either going to be moving up away from it or down from it, depending on what the a's and b's are doing. That's where you're going to get a range restriction, not a domain restriction, a range restriction, because it's stopping you on a y value. Does that make sense? As opposed to stopping you as an x value. Your x value asymptotes are domain restriction. Your y equals asymptotes, your horizontal ones are going to be range restrictions. They're going to be either above it or below it. Excuse me. This is so slippery. No, because they're not slippery over here. Yeah, I did dust.
Maybe just I don't think that they dust here because winds never dust.
I hear it's in the wind.
Where's that? I think it's a song, but like nobody knows it.
No, I think we get it. We're just laughing.
Oh.
It's okay.
It's okay, Mr. Ripley.
I don't get it.
Dust in the wind.
It's a
Is
song.
that a song?
By this.
Kansas.
I was gonna guess me.
Is it like a 1990s like hair band?
Hairband.
That sentence she just said.
No, what was that? It's got to be 77, 78. So it predates hair bands.
That's.
Google that for me, would you? Somebody Google that.
I will.
Dust in
Go
the
on to
wind.
Google.
What's that?
I said go on to Google.
Yeah, go on the Google and make that work for me, would you? What is it? Dust in the wind. Not dust in, wind.
No.
That's good.
No, wait.
78. It was recorded June through July of 1977, but it was released on January 16th, 1978.
Oh,
So
guess
you're both guys.
pretty good guess there.
Should be like,
So yeah.
I have a mind that's absolutely pure useless knowledge.
Kind of like Clay, except this is way worse.
Why are you comparing me with Clay?
Clay knows a lot of useless things.
He also knows a lot of useful.
That's true too. I might know a
I
couple
know
of
more
useful things
chemistry
as well.
things than him.
Clay just like knows all this weird stuff about like why dogs like do like certain things and what dogs are like brought over for what, and I'm just like, why? Like why Clay?
Yeah, dogs are important.
But like,
Anyway, let me give you guys day one stuff. They're really, I didn't want to get too much here. Is if your A value was positive, if it was 2 times 3 to the x, your A was positive, that means that the K value is below it. It's going up. Remember how the A, it shows you growth or decay? That's all. And to be honest, it doesn't really, there really isn't anything in here about an A value. Your guys will probably be using tables and just looking to see which directions it's falling. And then you're just, that asymptote will be thrown in. It doesn't even get that complicated either. This was more, to look at it like this was more than it was for right now. Because what we're going to look at is going to be something like this. Hey, look, it's not as crooked. Yay. Let's see. Give me one second. Can we sketch the graph using a table for this? Show it off. So let's say it's f of x equals 2 to the x minus 1. And we'll graph that via a table. That's about as complicated as a lot of this is going to get.
Are we doing this?
Yeah, let's do this.
oh, I thought we were doing.
One of the things that I would suggest as we're doing things like this, remember when we did these, we would label out what A, B, H, and K, all that were? And did you guys do that in Algebra 2? I know I used to have my guys do that all the time, label out what do you know, well, A is this, B is this.
Oh yeah, I think so.
when I would do that because it forces you guys to slow down a little bit and understand, well, H is your horizontal shift, K is your vertical shift, things like that. In this case here, what's the value of A?
One.
It's 1, because it's not there, it'll be a 1, because it's 1 times it. What's B? 2. What's H?
One.
H is 1, good, H is 1. And K, 0. So your parent function will be y equals 2 to the x. You okay with that?
Do you want us to go?
Wouldn't be a bad idea. I mean, if
It's kind of a waste of time.
it kind of is, because I think by now, since we're just using tables, we should just be able to go right from the table to the straight shift, right? Let's just do that then. So we pick our values. I'd like you guys to continue to use that -2, -1, 0, 1, and 2. I think they're pretty easy numbers that you can be able to do most of these things without even having to bother the calculator. So that means we're going to have 2 to the -2 minus 1, which is 2 to the -3. What's 2 to the -3rd?
1.
Very good. It's 1/8. You guys forgot your exponent rules.
Yeah.
Exponent rules. All
No,
right.
you do and then you just put a 1 over it. So like 2 to the 3rd and then put a 1.
Is that happy?
No.
No, it's not happy. Negative exponents aren't happy. They want to change where they are. Now it's happy. Is that happy?
No.
So you change it. Now it's happy. Negative exponents are unhappy in the part of the fraction that they're placed in. If they're in the numerator, they're negative, move them to the denominator, they'll be happy. If they're negative in the denominator, move them up, and then they're happy. Okay? So you get 1/8. One-fourth. 1/2. 1. And then 2. So everything just moves itself over. There's no vertical shift here, so you're going to have an asymptote at y equals 0. At -2, it's positive 1/8. At -1, it's positive 1/4. At 0, it's 1/2. At 1, it's 1 and 2 and 2. Okay. It moved the parent graph what direction? Move to the right. Move to the right. Because your H value is your horizontal shift. It means it moved it to the right 1, because the H was 1. Okay.
I bet
What is your domain?
all real.
Your domain is all real. What is your range? What's that? Y can't equal 0, but what will Y ever be below 0?
No.
No.
So all everything.
So your range would be Y is greater than 0. And that's where that came into play about where that K value, if there's a vertical shift. Since A is positive, it's above it. A is negative, B. That's how we deemed those. Okay. But it's just as easy to see via graphs. Okay. Let me give you guys the homework sheets on these things. You'll probably be able to, to be honest with you, I know you guys have all seen